Hello students, so this lecture is on finding the Twiddle factor for DFT. So we'll start with what is DFT. So DFT stands for Discrete Fourier Transform. And the formula for DFT is x of k equals to summation n equals to 1 to n minus 1 xn e raised to minus j 2 pi nk by n. So DFT is a discrete Fourier transform. So it is discrete in nature, and also x of k is nothing but k0 to n minus 1, where n is the length of the sequence xn. So length n is length of the sequence of xn. So x of k is also given as n equals to 1 to n minus 0. It is actually 0 to n minus 1. X of n wn is written as minus nk. Wn nk. So what is this wn nk? We can say this wn is nothing but called as Twiddle factor is e raised to minus j 2 pi by n. So this is nothing but this is called as Twiddle factor. So we are going to see how we can find this so that finding DFT is easier with Twiddle factor. Now you can see Wn is e raised to minus j 2 pi by n, and e raised to minus j 2 pi by n is periodic by n because it's exponential. So it is periodic by 2 pi n. So we can use the periodicity property to find Wn. So we'll start with finding W4. When I say W4 nk. So n ranges from 0 to n minus 1, that is 0 to 3. K also ranges from 0 to n minus 1, that is 0 to 3. So W4 nk will be 4 cross 4 matrix. Will be 4 cross 4 matrix. But let us find the values of this. So when I say W4 nk, this is nothing but this row stands for k. So this will be k equals to 0. This will be k equals to 1. This will be k equals to 2. And this will be for k equals to 3. And columns will stand for n, that is n equals to 0, n equals to 1, n equals to 2, and n equals to 3. Let us find W4 nk, that is W4, that is 4 cross 4 matrix. So when I write for the first row, you can see here the first row is for k equals to 0. That means it is W4 0. So what is the value of n does not bother. We have only k 0, so it becomes all W4 0. Similarly, when we see column 1 is for n equals to 0. So when I put the value of n here, this also becomes W4 0. So these all are W4 0. Now this row and this column are W4 0. Now let us find this row. Now when I find this value will be n1 and k1. So it will be W4 1. Then this value will be k1 and n2. So it will be W4 2. This value is k equals to 1 and n equals to 3. So it is W4 3. Now same way we'll go for this row. So n is 1, this value is n is 1 and k is 2, so W4 2. Then this will be W4 2 and 2 4. And this value, last value W4 2 and n equals to 3, W4 6. Then this is n0, k3, that is also already done. This value is k3 n1, so W4 3. Then W4 3 and 2 6, 3 and 3 9, so W4 9. So this values, now we'll write down the values of this. You can see here the second row, this is second row and this is second column. These values are same. W4 0, W4 1, W4 2, W4 3 and same as second column. Okay. Also we know that W4 is periodic by 4. When I say W4, you have to write, suppose I am writing here is k, this will be W4 k plus 4 or k minus 4. It is periodic by 4. So it repeats after value 4. So we can write these values. If you know starting 4 values, we can write the next 4 values for this. So we can modify this matrix and we can write that W4 0, we know that anything raised to 0 is 1. So all these values are 1. Right? Then we know second row and second columns are same. This is W4 1, W4 2, W4 3. This is W4 2, W4 3. Now what is W4 4? W4 4 by using this property is same as W4 0 plus 4, and that is nothing but W4 0. So this is nothing but W4 0, so this is 1. Now what is this? W4 6 will be equals to W4 2 plus 4, and it's periodic, so we can this directly write as W4 2. This we can say as W4 2. Right? Now what is W4 6? Same. This is also W4 2. Now last one, W4 9. What is W4 9? We can write W4 1 plus 8. 8 is the multiple of 4. It is periodic by 4. So this is nothing but W4 1. This is W4 1. So by this we know that only we have to find the values of W4 1, W4 2 and W4 3. If we get these 3 values, we'll get this matrix that is called as Twiddle matrix. So we have to find only these values. Now let us find these values and then we'll complete the matrix. Now what is W4 1? Let us see what is W4 1. So what is W4 1? So W4 1 is e raised to minus j 2 pi 1 by 4. That's the formula of W. Nothing but e raised to minus j pi by 2. That is equals to cos pi by 2 minus j sin pi by 2. And cos pi by 2 is known as cos 90, 0, and sin 90 is 1. So it is minus j. W4 1 is minus j. This we will remember and we'll fill the table later. W4 1. Now we have to find W4 2. W4 1 is minus j. Now what is W4 2? W4 2 is e raised to minus j 2 pi into 2 by 4. It is nothing but e raised to minus j 4 pi by 4 is e raised to minus j pi. There is nothing but cos pi minus j sin pi. And what is cos pi minus j pi? Is cos pi is minus 1 and sin pi is 0. The answer is minus 1. So W4 2 is minus 1. This is the second value. What is the third value? That is W4 3. You have to find 3 values only. E raised to minus j 2 pi into 3 by 4. This is nothing but e raised to minus j 3 pi by 2. So W4 3 equals to cos 3 pi by 2 minus j sin 3 pi by 2 equals to 0 minus j minus 1. Sin 3 pi by 2 is minus 1. So W4 3 equals to plus j. W4 3 equals to plus j. Now these 3 values, we know we have to just fill the values and get the matrix. So what is W4 1? Minus j. W4 2 is minus 1 and W4 3 is j. So we'll just fill the values and we'll write the matrix here. So this value, the final matrix is, these all values are 1. The first row and first column is 1. What is W4 1? Is minus j. We got W4 1 as minus j. W4 2 we got as minus 1. W4 2 is minus 1. And W4 3 is plus j. W4 3 is plus j. Same again W4 2 is minus 1. This one is minus 1. This is 1. W4 2 is minus 1. W4 3 is j. W4 2 is minus 1 and W4 1 is minus j. So this is your complete matrix W4. I'll write it again and I'll tell you the properties. So what is the final W4? we are getting is, you can just see the values above. These all are ones. First row and first column is 1. Then this is minus j, this is minus 1, and this is j. You can see the second column. The sum of elements of the second row is 0. This is the property of W matrix. This we can see again here. We are copying from here only, right? Yeah. And then this is minus 1 and j. You can see the second row and second column, the values are same. So once we get the second row, we can directly write the second column. And the sum of row and columns is always 0. This is 1, this is minus 1. This is minus 1, this is minus j. So you can see the sum of any row and any column is 0. And this is also one of the property of W matrix, except first row and first column. So this is your W matrix. So we'll just write the properties of Twiddle matrix, Twiddle value, Twiddle matrix here. So what is that property? It is periodic. What do you mean by periodic? That Wn will be equals to Wnk will be equals to Wnk plus n. Second, first row and first column will always be 1. Third, addition of elements in a row or column is 0. This is except first column and first row. Addition of elements in row and column is 0. Fourth is, you can see the fourth one, the second row is same as second column. Third row is same as third column. You can see third row is same as third column. It is except first row and first column. Okay, so these are the properties, and thus we can say this is the Twiddle matrix. So using this Twiddle matrix, now we'll be seeing the next video how to find the DFT of any sequence.